Hello children. In the previous session, we discussed or we studied about the lesson Introduction to Euclid's Geometry. There we studied what are axiom, postulates and various other basic definitions, and also learned which the 5 postulates and axioms are given by Euclid. So today we will be starting with the new lesson, that is next geometry lesson, lines and angles. This is also one of the geometry chapter and we will be studying about few new concepts in this lesson. Before starting with the actual lesson, let us just recall the few definitions which you have learned in your lower classes. First one is a line segment. You all know these definitions, children, so I will be glancing it very fast. A part of a line with two end points is called a line segment. So if you draw just a line and if you keep two end points, two dots at the ends of the line, that is the end points, then that is called the line segment. In any given figure, in terms of words, if you are representing a line segment, suppose if you label the line segment as AB, you will draw like this. If asked to write in terms of words, means you will write it in terms of letters, means write AB and put a bar or line on its head. This is how you represent the line segment geometrically. Line segment AB, if you write, means you should not write in words, line segment AB. Instead, write just AB and draw a bar or a line upon it. So, this is how you represent the line segment. It is a part of the line with two end points. If at all a line has only one end point and one arrow mark, then it is called a ray. Look here, you have only one end point and towards the other end you have an arrow mark, which means it is continuing. The line is continuous, but these two are the end points. The line is no more continuing. One of the end and other side is continuing. This is the ray of line. Next are collinear and non-collinear points. Even this concept you know, children. If the points are such that when you join them, if they form a straight line, such points are called collinear points. If they are not in straight line, such collinear points are called non-collinear points. Next is angle. You have been introduced to these things in lower class itself. What is an angle? It is formed. Angle is formed when two rays originate from same point. Now, look at this figure. Suppose if I mark the intersecting point or common point as O, from O, the line OA is generating. Similarly, from O, OB is generating. So, these two line segments have common vertex or common point. So, this forms an angle. So, angle is formed when two rays originate from same end point. After knowing about angle, we will study about the types of angles. You all know acute angle, obtuse angle, right angle, reflex angle, complete angle, all that you know, children. So, acute angle means the angle which is less than 60 degree is called acute angle. Which is equal to the angle which is equal to 90 degree is called right angle. Representation also you should know. This is how you represent right angle. If at all the angle is more than 90 degree, then it is called obtuse angle. Greater than 90 degree means obtuse angle. If the angle is equal to 180 degree, then it is called a straight angle. If the angle is greater than 180 degree but less than 360 degree, then that angle is called the reflex angle. If the angle is equal to 360 degree, then it is called a complete angle. Acute less than 60, obtuse more than 60, equal to 90 right angle triangle. Equal to 180 degree, straight angle. More than 180, less than 360, reflex angle. Equal to 360 degree, complete angle, one complete circle. These are the types of angles. Next, you also have complementary angle and supplementary angle. Complementary angle means if at all when you take the sum, SUM sum, when you take the sum of two angles, if at all it is equal to 90 degree, then such angles are complementary angle. If their sum is equal to 180 degree, then that angles are called supplementary angles. So, complementary, supplementary. Complementary under 90 degree, supplementary under 180 degree. Sum of two angles is 90, sum of two angles is 180 degree. Next you have adjacent angles. To explain you that, I will consider a quadrilateral or a say parallelogram A, B, C, D anta one quadrilateral I will take, children. Now it has four vertices, which are the A, B, C and D, right? Now AB is one line segment, BC is one line segment. AB and BC have one common vertex, that is B, vertex B, correct? Now BC, CD, if I take BC, CD, C is the common vertex, isn't it, children? So BC and CD are adjacent sides. Now I will consider CD and DA. CD hige, DA hige. They have one vertex in common, that is D. So CD and DA are adjacent sides. So this is how you represent the adjacent sides. Next you have about the linear pair, children. If a ray stands on a line, the pair of angles found on either sides are called linear pair of angles. On a line, if a ray stands, the pair of angles formed are called linear pair. Pair, you know why. Why linear? Because it is on the straight line. So, linear pair of angles, and the angles so formed, that is sum of their angles A plus angle B will always be equal to 180 degree. That is, linear pair of angles are supplementary angles whose sum is equal to 180 degree. That is about the linear pair. Next you have VOA. What is VOA? Vertically opposite angles. So these two lines are there, children. They are intersecting at one point O. So these two single arcs are vertically opposite angles. These two lines which I have written, these two are vertically opposite angles. Here in the parallelogram, if you want to draw, just draw the a diagonal. AC and BD are the diagonals. These two diagonals intersect at point O. These two angles are angle BOC and angle DOA are vertically opposite angles. Similarly, DOC, AOB are vertically opposite angles. Intersecting and non-intersecting lines. This is too much basic. If the lines are parallel, means even if you extend however long, it never meet or it never intersects. Such lines are non-intersecting lines. Here only the two lines intersect at the diagonal. Similarly, if the two lines intersect, they are called intersecting lines, children. So these are the few definitions or idea what you need to have in order to study this lesson. All that things you have in your textbook. So what I want you to do is, I have just picked each sentence up, but they have elaborately explained in your textbook. So what I want you to do is, as soon as you go this video, children, just make a pointer like this and write down all the definitions. 5, either 6, 7, 8, 9, 10 and 11. 11 points if you write, that is enough. Just write by looking at the board or hearing into my explanation. It is up to you. Or if you want to write from the textbook, yes, you are welcome. You can write that. So after this basic definition, next we will be studying about the pair of angles. Just now I explained to you about the linear pair. Which two angles are said to be linear pair? If a ray stands on a line, the angles made by this ray of light on the line, I went to physics. This ray of light a ray makes an angle on the line. The two pair of angles so formed are called linear pair, and it is supplementary, means it is equal to 180 degrees, children. So that is about the pair of angles, and you have axioms 3.1, 2 and various theorems you need to learn here. You have proofs of few theorems, but axioms, you know, yesterday, in the previous session of Euclid's geometry, I taught you what are axioms and what are postulates. Axioms are the sentences or the concepts which are universally accepted but not proved. Hence, for axioms you will not have the proofs, but for theorems we will be having the proofs. You have various axioms here. So axiom 3.1 you have in page 43 in your textbook. I just want you all to write the statements of all the axioms in your classwork. Axiom 3.1. If a ray stands on the line, then the sum of two adjacent angles so formed is 180 degree. That is what we learned in case of linear pair. If a ray stands on a line, then the pair of adjacent angles. Just now I explained you what are adjacent sides. Similarly, children, if one angle is beside the other, then they are called adjacent angles. For angle A, angle B is adjacent angle, angle D is adjacent angle, but angle C is opposite angle. Similarly, for B, angle A is adjacent angle, angle C is adjacent angle, but D becomes vertically opposite angle. For angle C, D and B are adjacent, A is vertically. Similarly, for DC and A are adjacent, whereas B is vertically opposite angle, like that. So, the adjacent angles here formed here when a ray stands on a line. The adjacent angles so formed are supplementary, means it is equal to 180 degree. That is what the statement of axiom 3.1 states. Next, you have axiom 3.2 in page 44. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. It is just the converse of this axiom 3.1. If a ray stands on a line, the adjacent pair of angles formed are called linear pair and their sum is equal to 180 degree. That is what we learned. What does axiom 3.2 states means? If the sum of two adjacent angles is 180 degree, then the non-common arms, see, if a ray is standing on a line, these are not common. Then the non-common arms of the angles form a line. Then the non-common angles of angles form a line. This becomes a line. Then it is just the converse of it. Next you have theorem 3.1 along with the proof, children. This is very, very important and we will be studying the proof of theorem 1. And you have various example problems given here. Once you know the concept, you can go through it, children. I will be starting with exercise 3.1. Today, we shall complete it. Before that, I will explain you the theorem 3.1. I want you to write this complete theorem starting from statement, proof, construction, figure to prove that whatever is there, everything we need to write. Next, we shall study about theorem 3.1. Statement is, if two lines intersect each other, then the vertically opposite angles are equal. Now you know what are vertically opposite angles. So two lines intersect means of course it should intersect such way. They should cross each other. So we have two lines, that is AB and CD, which are intersecting at point O. Then the pair of vertically opposite angles formed are equal. We need to prove according to the theorem. So you can see angle AOC and angle BOD with single lines or single arcs are the vertically opposite angles. Similarly, angle AOD and angle BOC are other pair of vertically opposite angles. So we need to prove those vertically opposite angles are equal. That is what I have written. TPT means to prove, that short form. Not it is only for me, children. You have to write full. To prove that angle AOC is equal to angle BOD and other pair of angle BOC is equal to angle AOD. AOD, BOC, BOC, AOD. You can interchange, that doesn't make any difference. So we need to prove that. Here we have the proof, which is very, very, very simple. So we will consider, I will draw it here for you. We studied the concept of linear pair that we are applying here. If we imagine that OA is a ray standing on the line CD. This line CD is there, no? That I will draw like this for you. This is line CD and idu OA idiyalla. If you imagine that as the OA anta tagondre. If we think that OA is a ray standing on the line CD, then this ray will make two adjacent angles, will give rise to two adjacent angles. Which are they? Angle AOC, one angle. Angle AOD is other pair of angle. We know that a ray which makes adjacent angle with the line are supplementary, means their sum is equal to 180 degree, we know. So in the proof, that is what they have done. OA is a ray standing on the line CD, then angle AOC plus angle AOD is 180 degree. How can you say? Because they are linear pair. Children, in geometry, whatever you write, even in the theorems as well as while solving the problems, always you should give reason in the brackets for whatever you write. That you know, you have learned in 8th standard. So now I am writing based on this, angle AOC plus angle AOD is 180 degree. Why? Because they form the linear pair, and I am calling it as equation 1. Next, you have, now we proved angle AOC is angle AOD. These two, this plus this is 180 degree anta we proved, but that is not our aim. We want this angle BOD, alva. But angle AOD and angle BOD or DOB are adjacent pair of angles. Children. Hence, I can write angle AOC plus angle BOD is equal to 180 degree. AOC, BOD. AOD, yeah, sorry, I did mistake. It is AOD and DOB are adjacent angles. So I can write the pair of adjacent angles are also supplementary when a ray stands on a line, children. So in the next statement I can write angle AOD is equal to angle DOB plus angle DOB is again 180 degree. Reason again in the bracket you will give adjacent angles are supplementary. Adjacent angles are supplementary. In the textbook they have not given the reason, they have asked you why. So you should tell. I will call it as equation 2. Now on adding or comparing equations 1 and 2, children, on the RHS we have 180 degree in both equations 1 and 2. So when you equate those two equations, since RHS of the equations 1 and 2 are same, we can equate their LHS. Like angle AOC plus angle AOD is equal to angle AOD plus angle BOD. Angle AOC plus angle AOD is equal to angle AOD plus angle BOD. Now angle AOD and angle AOD you can cancel off. Then you will get left with angle AOC is equal to angle BOD. Go back to figure. We got angle AOC is equal to angle BOD, which means these two vertically opposite angles are equally proved. So this is one pair of vertical angles. For the other pair of vertical angles also, children, if you consider OB as the ray standing on the line CD, again these two angles form the linear pair. If you find out one angle, the other pair becomes the this becomes the adjacent angle, and hence you can consider again the same steps you will do, but only ray line is also same, only the ray will change. So hope you will do it. When you do so, you will get AOD is equal to BOC. Hence we proved if the two lines intersect each other, then the pair of vertically opposite angles so formed are equal. That is about the theorem 3.1. Next we should start with the first exercise, that is exercise 3.1, based on this axioms, theorems and its concepts. We have 6 problems.